Okay, everyone, I'm going to go ahead and give you some information for Unit 2 about proportional relationships. First of all, there's a lot of different ways to look at proportional relationships. You can see them as equations, data tables, graphs. So being able to interpret that information to find out if something is proportional is important. There's a couple of ifs. If ordered pairs show a constant ratio, so that would be looking at a graph more than likely, although data tables also have ordered pairs, which is why in these examples they're labeled X and Y. Okay. If elements in a row of a table have a constant ratio, so if you're looking at the table information that I have below and you're looking at the row in there, you should have a constant ratio. So if I'm looking at X and I see that it is 1 to 3, sorry for drawing on there, okay, then when I go over to the next one and I see 4, it's a ratio of 3, 4 times 3 to equal 12. Okay. Then I move on to 7 times 3, which equals 21, and 10 times 3 that equals 30. Okay. I don't have to list them all out in multiples of 3 to be able to see this pattern. It does show up consistently, so it has a constant ratio. There is a constant ratio between X and Y coordinates or points on a graph. So if you're down below, you're looking at the graph, you will notice that Y is going up, X is going across. You always label X first, just like alphabetically, X then Y. So if 1 on the X-axis meets up with Y on the Y-axis, that is the unit rate. If it continues in that same unit rate pattern and all those points line up to go through the point of origin, then it is called a relationship of proportionality. Okay, origin is important. You will also notice that these are always in a straight line through the origin. If it doesn't do both of those things, then it is not proportional. Okay. Another item that was listed, if a relation can be expressed algebraically in the form of the equation y is equal to kx. And just so you know, k is actually the constant of proportionality, okay, and is often another way of expressing the unit rate. Okay, if you can take the unit rate, the constant, and multiply it by x, you can come up with all the values for y. Okay, as you can see, we actually did in the data table. Okay, so in the data table, the constant was times 3. So every time I multiplied a letter x, the number there, 1 times 3, I got 3. 4 times 3, I got 12. 7 times 3, I got 21. So I had a constant in proportionality. Okay, so there are a lot of different ways you can see it. A couple other details I can point out here. If you are missing the value, you're trying to calculate it out, okay? Equal to, equal symbol, as a side note. The squiggly lines are approximately equal to, depending on how much we have to round here. But if I had x, which is the unknown, over 13 is equal to 18 over 39. Right? These could be equivalent ratios, which the vocabulary covered. But in order to solve this without having to try to calculate, well, what did I multiply 13 by to get 39? I can actually get rid of the 13 on the left side of the equation. Okay, right now, if I multiply x and 13 by 13, the 13 cancels out, and I'm just left with x. On the other side, of course, I have to do the same thing. Therefore, I put 13 times 18. And now my new equation leaves x all by itself so that I can solve for it. And I have 18 times 13 divided by 39. Another way people have heard about this is that it might be expressed by saying cross multiply and divide, where you would take these two numbers, multiply them, which is what I said over here, and then divide by the remaining amount to find out x. So if I multiplied those two and then divided by 39, I would end up finding out my answer. Okay. Quick point I want to make with you guys is that you can use a calculator on this. Showing my work is what I did on the screen. Now I'm ready to type that into the calculator with 18 times 13 equals 234. And then I divide that by 39 when I get 6. So in my response, I would say that x is equal to 6 because I had 234 divided by 39. Okay. This gives me the value I was trying to solve for. So again, more explanations